multiple choice questions on ideal gas equation. I couldn't find a way to get rid of the answers because it's already highlighted in red. But I'm going to show you how you do this. So a sample of this much has a volume of this, the pressure of this, what's the temperature of the gas. Obviously we're using ideal gas equation. PV equals nRT. We're trying to find the temperature. T is equal to PV divided by nR. So that's the first step. Rearrange the equation. Now I need to convert these into its correct units. Pressures in pascals, that's in kilopascals times by 1000. This volume needs to be in meters cubed. Remember, for ideal gas equation, volume measured in meters cubed. So meters cubed, dm cubed, centimeters cubed. This is how I'm going to learn it. To jump from one to another, you times by 1000. To go backwards, you divide by 1000. We want it in meters cubed, and we're given centimeters cubed, so we need to divide by 1000, then divide by 1000 again. So we need to times by 1870 times by 10 to the power minus 6. We're dividing by a million. Divided by number of moles, 2.18 of oxygen gas, MR is going to be 32, times by R, 8.31. If it's not given in the question, it's always going to be 8.31. You can assume that. 1870 times by 10 to the power minus 6. We divide by a million because we want it meters cubed and the centimeters cubed. 2.18 divided by 32 times by 8.31. And look what we get. We get 333.6 Kelvin. Therefore the answer is B, obviously. And obviously if you didn't use the correct units, you probably would have got that, which is wrong. Question 3, again, it's got the answer. Which of these samples of gas contains the largest number of molecules? What we'd have to do is find out the number of moles and then times by, and then because we're timesing by 6.022 times by 10 to the power 23, that as soon as we find out the number of moles, the one that has the largest number of moles will have the largest number of molecules. PV equals nRT, and all we need to do is find out number of moles. N equals PV divided by RT, and I'll find out each and every single one. Pressure 1.0 times by 10 to the power 6 times by volume 5.0 times by 10 to the power minus 4. It's already in its meters cubed, which is correct. Divided by 8.31 times by 300. That gives me 0.201 moles. For the rest, second one, 4.0 times by 10 to the power minus 3 times by pressure 2.0 times by 10 to the power 5, it's already in pascals, divided by 8.31 times by temperature 400. There we go, 0.241 moles. And in this case, well, we've got it in dm cubed, one in meters cubed, dm cubed, centimeters cubed. Just how like D block is in the middle of the periodic table, dm cube contains D is in the middle of these two. So I want dm cubed and I want it in meters cubed, so I need to divide by 1000 this way, times by 10 to the power minus 3, aka divided by 1000. So 3.0 times by 10 to the power 1 times by 10 to the power minus 3 times by pressure 3.0 times by 10 to the power 4, 3.0 times by 10 to the power minus times by 10 to the power 1 times by 10 to the power minus 3 times by 3.0 times by 10 to the power 4 divided by 500 times by 8.31, 0.217 moles. And for D, 2.0 times by 10 to the power 2 times by 10 to the power minus 3 times by 4.0 times by 10 to the power 3 divided by 8.31 times by 600, 0.160 moles. And that's why the answer is B, because it contains the largest number of moles and therefore largest number of molecules. To find the number of molecules, all we're doing is times by 6.022 times by 10 to the power 23. So if this number is already bigger, we're going to have a large number of molecules. And then question 1, 30 centimeters cubed of Xenon mixed with 20 centimeters cubed of fluorine. Well, it's got 1-to-1 molar ratio. Therefore, you can clearly see Xenon's in excess. So we've got 30 minus 20 is 10 remaining. So that's 10. And obviously, that's a 1-to-1 molar ratio. And that's not in excess, so that's 20 as well. So then 10 plus 10, 20 plus 10 will give you 30, and therefore the answer is 30. And that's the end of multiple choice questions.